that you can hear us. My name is Branka Dimitrijević and I will moderate today's event. Our seminars and webinars disseminate outcomes of feasibility studies and academic consultancies undertaken by researchers at 7 Scottish universities and small to medium-sized enterprises operating in Scotland. The focus of these studies is on sustainable building design and refurbishment. The project is funded by European Regional Development Fund and Scottish Government CIC program, which is currently managed by Scottish Funding Council. A few event management points. If the event is interrupted by a fire alarm, we hope it will not happen, we will stop and then continue, if possible, at the end of the fire alert. If our online viewers are not able to join us following a potential fire alert, they will be able to access the event video recording on our website in a few days. We plan to finish the presentations around 1:30, and our online viewers can start using chat facility at any time during the presentation. The questions will be answered at the end of presentation. The event will close around 2 o'clock. If some questions could not be answered until then, they will be forwarded to the speakers to answer by email after the event. We now offer a live transcription service as part of our online broadcasts. The presentation is transcribed live in a pop-up window as the webinar takes place. By providing this service, we hope to make our webinars as accessible as possible. The instructions are provided in a login email that you have received this morning. So today's webinar title is Sustainable BIM-Driven Post-Occupancy Evaluation. This was a study undertaken by Heriot University for Wylie Shanks architects. Our speakers today are Dr. Ibrahim Motawa of Heriot University and Wendy Corrigan of Wylie Shanks architects. I would kindly now ask Dr. Ibrahim Motawa to start with his presentation.
Good afternoon, everybody. And I would like just to start my presentation by looking at the title that we have here. Yes. So our project is about sustainable BIM-driven post-occupancy evaluation for buildings, and from the title actually we have 3 keywords actually we can look at: sustainability, BIM, and post-occupancy evaluation. And our study actually will cover, or first we covered a number of issues about sustainability and how BIM is used in the industry, and then we focus more on the post-occupancy evaluation because usually BIM is used in industry mostly for design and construction stage only. So we have our focus is on post-occupancy evaluation. The presentation will have these elements. We will give first I will give an introduction about the study itself and the background on the idea, and a few information about the methodology that we followed to achieve the objectives of the study, and then move to the main finding from the study. Wendy will share with me in this part. And then we will finish by the conclusions and the way forward that this study reached to. First of all, the background behind the study, which I will just give brief on that. Over the last couple of years, there is a lot of reports, governmental and industrial reports, which actually try to identify the problems of energy efficiency in buildings and the carbon emissions and the UK target to achieve this CO2 emission targets. And these reports actually and the initiatives try to identify approaches to be followed by the governmental bodies or by the industry and the contractor and all the construction partners. One of these approaches and initiatives actually talk about information exchanged among all players or the stakeholders in construction. And they talk mainly about consistent information across all stages of construction, and all players should get the same type of information. They should understand it at the same level. So this to improve the accuracy and correctness of the information. Of course, this by the end will help them doing correct decisions on any issues they are tackling with. As well, part of these reports talk about the governmental role as a client, which means that the take-up of technology like BIM will need huge investment, and majority of clients are, can say, are in doubt in the use of this type of technology in terms of return or the savings or whatever financial issues they are concerned with. So they look at government as a major client, and they say, okay, the technology will be in place more if these major clients take the lead in this field. So we have as well part of the reports which issued by the government as well, both some targets for all governmental or the government departments, that all projects over 50 million should have this element of technology to be used from 2016. So this is one of the targets now. So that means the issue becomes required for all governmental departments who actually work with such huge type of projects. So that means in the near future we will find some changes in the way that the construction industry works and operates, and the procurement actually strategy should be as well amended and should take care of this type of changes. So this is for the background that we based our work on. While we, of course, from the research point of view, there is a lot of work that had been done in terms of using BIM in construction, but again, as I said, mainly for design and construction stage. So that means this study looks more to the post-occupancy evaluation, and that means we should look at how BIM can be used for post-construction. In terms of BIM applications for energy analysis as well, there are a lot of applications that are already available, and but again, for design stage, we have a lot of energy tools and technology that used for designers, architects, or energy managers or so, who can try different type of materials or different type of design and see how the energy performance will be. So they have this kind of facility available now. But again, if we look at the after construction, so usually majority of buildings actually don't perform well as planned, as it should be. So they need to monitor the building, have some other type of maybe changes or some certain type of instructions for using building efficiently. So there's a lot of issues after construction that should be monitored and recorded. And there should be a certain type of tools that help the stakeholders to take this type of, or to collect this type of information and analyze it somehow, and then reach up to certain type of decisions that help them actually put the building on the right track in terms of energy use. So this was the background of our study, and we try from the study to achieve just simple objectives to look at post-occupancy evaluation in public buildings in Scotland and identify certain type of or the key type of variables that needs to be embedded in BIM models, and the information or the operational information on carbon performance and energy use, and see how this type of data help decision makers or management in public buildings to control or to save energy, if we can say. So this will, by the end, help us achieve the aim of the study to ensure consistency of clarity to the supply chain in general, because we will see from the outcome of the study that there's a lot of information needed, not only from the building that the public departments are using or occupy, but also from outsider. The methodology that we followed to achieve this objective is to have few interviews with a number of professionals in the Scottish public departments and industry practitioners. And you have here on the slides the list of participants who we met with, different departments. Of course, we tried to have a variety of departments. So we have Historic Scotland as one of the major clients, public or governmental department. And we have a number of councils in Scotland, and we have as well some or few or sample, we can say, from the consultant in terms of sustainability and the energy assessors. So we try to cover different type of to integrate different type of stakeholders, you can say, who are involved and are concerned about energy use in buildings. And the main aim of the purpose of these interviews is to investigate how they actually run their buildings, how they monitor the behavior of the building, and collect data on, of course, our study is mainly about BIM, so we try to as well to see how BIM technology is used, if it is used, and so we can say as well, if they are aware of the type of technology, that how it can help them in doing their tasks, or if there any potential for using BIM in this type of tasks or not. And we as well collect data on the type of technology they are using currently to assess operational and carbon performance in terms of any type of devices or sensors or meters or readings or meter readings or so from project sites. And by the end, how they involve the supply chain members with them, and when they come to make decisions about buildings. So this type of data we try to investigate and collect and try to build on that to see how can we use BIM for post-occupancy evaluation. Part of our findings, so I'll just try to give you a brief on what we found from this investigation. Generally, as you can see, this diagram shows us the typical construction stage for any building: design, construction, operation, and demolition stages. And of course, because we in this study we focus on operation stage, so we look at it in much more detail. Again, is typical structure for controlling energy in buildings. We have site level, control level, and management level, and there are a lot of information coming from each level to the other. So, for example, you find at the site level the building itself in different locations, and then the upper level is control level. So we collect data from sites to control middle level, which collect data from different sites. So a kind of data management, and then the management level, which is mainly about decision making. So at that level, decision should be made for any type of problems in size or energy, or for energy use in any building. Of course, we have covered in this study different type of buildings actually, or the information we got is about different type of buildings. It depends on the business function of the building. Like we know that councils actually look after schools, look after local library or public library, look at as well community centers. So different type of buildings. Historic Scotland, for example, have a lot of buildings as well in terms of they have their own type of nature, and they have to have their own plan, different plan from the councils in terms of maintenance and energy use. In general term, each department from those we met with actually are looking after almost, or on average, 250 buildings to 300 buildings. So this is quite huge type of work to collect data from all buildings and analyze this data somehow. In terms of the team who are actually supervising this type of process in this building or public departments, again, the variety of structure, you can find the energy team who actually consist of few people, or maybe larger than that, tens or so, and who may be highly visible. You can say they are in the structure of the organization, or maybe hidden behind other business team. So there is different type of management structure which are looking after energy in buildings. So if we call them all as in-house team, so those are looking after buildings in each department. There are as well somebody who are linked with the public departments from outside, those who actually issue the energy performance certification. So they always have this external team who come and investigate. Of course, majority of buildings now are certified, but mainly or majority are by external team or consultant. So this is the general kind of structure we found in public departments in terms of energy management. For each level that we looked at, so we have site level, as they say, and control level and management level. We try to identify the sources of data and the information they need, how they collect it, what they are doing with this data, what analysis they are doing on this type of data, and how that could be linked with BIM models. So for example, for site level, you find here majority of buildings are now equipped with AMR readings, meter readings, so automatic meter readings. So that means majority of buildings now can easily or monitor the energy use in buildings can easily be monitored or recorded. While there are few other buildings among these buildings as well that are monitored by just manual reading or by manual meters, which is still very few, and others by sensors with very high technology if they use it, while it's not that common yet. And still some other buildings which rely on suppliers, the energy suppliers, the energy company, so they provide this type of facility to record the energy use in buildings. So this type of data is collected. You can say here as I can say just examples of the sources of this data, and this data is collected through different systems, so collected at the control level by what we call building management systems. And this management systems actually is a kind of database, huge database that collect this data from sites. And in addition to the data coming from sites, they actually, I will just move to the next slide to show you the structure of type of other data that they collect at that level as well. So the site details comes from sites, which is data required about the building itself, the location, the space or the zone spaces in the building, the occupancy, the capacity of the occupancy, and the population, the hourly use of the building. So a lot of information needed to be collected. Also, they should have information about the building specification, materials used, any type of history about the building, any maintenance stuff happened before. They have weather data or degree day adjustment to heating suppliers, so they need type of thing which is standard for the environment that should be used to adapt the kind of temperature needed in buildings. And of course, the site level bring to the systems what we call meter details about everything about the actual use of energy, in addition to the information provided by the suppliers, like tariff, like VAT rate, the invoices, so anything related to costing and finance. So this type of, again back to the diagram here that shows us at the control level that all this type of data should be collected, and we should have very strong management systems or data management system to collect all these type of data. Of course, again, in practice or there are a lot of available softwares which can help in that. Majority of departments we met with are using software like System Links, and there are other type of softwares which I can. We have a list of softwares which are in use, but this is the majority, or the majority of them are using these systems, which again is just a type of data management systems. Very few buildings actually are equipped with intelligent automation building systems, which help as well automatically control the energy use in buildings. But this is, of course, quite expensive type of systems, so it's not that common yet. Again, the analysis part of this data at that level is quite limited, and even this type of data management systems are not that complicated, so it's just a kind of data organization, kind of different, so can produce different type of reports in different type of formats based on who is going to look at it. So there is no much analysis here in terms of energy analysis. So what energy managers are doing at that level is to use their own type of expertise, or another type, or maybe other type of softwares, so they can integrate this, but manually, to take some data from these management systems to perform any other type of analysis, more sophisticated, related to energy use. So in this case, there is no link. There is no link between what we collect from sites and what we need and what we do in terms of analysis. So again, it is an area for BIM to be used here. Once we collect this type of data, we come to the higher level, management level, which mainly where the decision should be made. So decision analysis, in addition to this type of data, they need as well other type of information and data which could come from manufacturer, for example, supply chain, databases and documents. So they need to know about, for example, new technology, new type of materials to be used, maybe to improve that type of elements in certain buildings to improve the energy used by the end. And as well, they are constrained by different type of strategies or regulations in terms of environmental or financial issues, so we need to have access to this type of data as well to help them making the right decisions. There are other issues which is quite important as well at that level, is to link with the occupier of the buildings or the user of the buildings, which we found it one of the key problems actually to have buildings energy efficient used actually. So the link with occupant is one of the issues that we think of actually. How can that be done in terms of modeling to link or to make the occupant, the end user, part of the decisions, or to be informed or to be influenced by the output of the analysis. So this is the kind of, you can say this is one of the findings that we reach up to get this picture about energy management in public buildings, what type of information is collected, and by what means, and how the decision should be made at the management level. The other element, or one of the other findings as well that we looked at, is how the buildings are certified as energy efficient. So the process actually, which is followed in majority of buildings, which is the national calculation, using the national calculation method, again, is done by consultant, energy consultant, or energy assessors. And they again follow this type of sequence in terms of data collection, and they do some calculations based on the methodology and NCM methodology. And then they compare the analysis, the output of this analysis to a national or a normal building, which again a standard building, which again according to the regulations here in the UK, either there is a slightly different you can say regulations between England and Scotland in this respect, but almost they follow the same process. And then the issue by the end, the EPC for all buildings. So here, there is a lot of issues about this process. The energy assessors are saying it is not that accurate. Actually, at the moment, the methodology of NCM is not that accurate because of mainly because of the simplicity of the method. There is a lot of buildings that themselves are so complicated than the way that they follow in this process. But again, this is not our target in this study. But the issue here is that how we asked the energy assessor how BIM can help them improve this process better than they are doing now. So what we found again that the type of data they collect, of course, majority of this building are existing buildings. So there is a problem about the data or the site details or building details in terms of dimensions, in terms of orientation, in terms of the building model itself. So there's an issue about that. So they should do that manually, so that or use some maybe advanced technology, but still they have to collect data by themselves and enter data into their type of software they use afterwards for calculation and analysis. So there's a lot of issues here which again make the use of BIM here has some potential, while there are a lot of complication in this if we follow the same national calculation method, because the current software which is used for this analysis is not, of course, compatible with this new technology, BIM technology. So that means if we need to use BIM for this process, that means the current software used for certification should be developed further. So this is one of the problems. But again, it is part of the process of energy management in terms of certification. The expectation actually that we feel, just back to my first presentation, my first slide about the overall process of energy management. Now we have two teams, one in-house and one outsourced, or the two teams. At some levels they use, we can say, same type of data in terms of at the site level. So they need to know about the building specifications. They need to know about the use of building, how it is used, and of course they are sharing the same type of problems actually when they come to make decisions. So when we look at BIM as a technology, so BIM is a kind of ICT frameworks which include different type of tools and technologies that can be integrated together to support stakeholders, to collaborate, to collect data from different type of design teams across all the project life cycle. So this type of technology will help a lot, and of course it is actually approved now by a lot of practitioners and users that BIM will improve the way that construction operates. And as I mentioned at the beginning, that BIM tools in terms of energy analysis actually is as well is now used somehow. There are a lot of softwares integrated now with BIM and compatible with BIM technology and can be used, but still, as I say, at the design stage. So the next step which we are looking at is to how that can be expanded to be at the post-occupancy as well. I will stop here and let my colleague Wendy to continue to talk to us about other part of the findings that we covered in this study. So, Wendy.
Thank you, Ibrahim. I'm going to take some time to talk a little bit about the bigger picture of BIM within the industry as it is today. There's a compelling argument for the use of BIM, the ability to create a data-rich digital model which can act not only as a construction model for the design team, a financial model for the client, and ultimately a facilities management model for the end user is exciting. The ability to assess both capital and environmental costs right at the outset of the project and to use this information to reliably inform your design process is very worthwhile. Ultimately, it's a tool that you can use to test the initial model, the virtual model, to check the model throughout the design process. Any changes in design can be reassessed and then evaluate the finished building at the end stages. So with this obvious value that BIM can bring to design and practice today, what is its general usage in the industry? One of the guidelines that we can use is a survey that's been prepared by NBS on behalf of REBA Enterprises. They carried out a study in 2010 and 2011 where they sent out electronic questionnaires to people across the industry to find out what the usage was. What was found out in the most recent study is that 35% of people across the industry are not using even CAD at all, though that mix varies depending on the sector. So in architecture and architectural technologists, it's close to 90% of people are using CAD now, whereas surveyors, quantity surveyors, could be much lower, the figure. When you look at BIM, 31% of people of the people who are using CAD, 31% are also using BIM. But on the flip side of that, 21%, that's 1 in 5, are completely unaware of BIM's existence, so obviously there are challenges there to be met. Though interestingly, of the 65% who do use CAD models, of people who do use CAD currently, 65% are using CAD models in some way to carry out energy performance analysis. So to accelerate the use of BIM, there are certain barriers to be overcome. And through talking to people throughout our study, there were 4 main headings that these concerns could be grouped under. These are cost, control, communication and compatibility. I'm going to take a little bit of time just to speak about each one in turn. Cost is a fairly obvious concern and an understandable concern, not just for the capital investment in the first place, but also for training time and potential downtime while people get used to the technology and maybe have periods of less productive work. There's a ballpark figure being put by a number of surveys at approximately £10,000 investment required per workstation to cover hardware, software and training, which can be quite a significant barrier to change. But in reality, a big barrier to change is also the process change. There's a big shift required in just general the way people work. So there's a potential here for small to medium enterprises to almost be more agile in this respect. There are fewer people to convince of the benefits of the technologies, so should be able to respond more quickly to the challenges. Interestingly, in the NBS survey, 63% of respondents did believe that the change to BIM or the move towards BIM for construction was too expensive at this time. Control is also a big issue that came up in a number of occasions. With traditional contracts, the process was clear, or is clear, where responsibility moves from perhaps the design team to the contractor and then to the end user. The collaborative environment of BIM requires people to work more alongside each other, which means there are multiple data sources that need to be coordinated and possible conflicts of interest that need to be coordinated as well. And of course, once the building is complete and handed over, there's the ongoing BIM maintenance that needs to be considered, who is responsible for the maintenance of the model. It's believed that over the next year or so there will be a lot of new insurance schemes and contractual relationships that will be built up around the BIM model to try and accommodate or alleviate some of these concerns. The ownership of the model has been raised as a question on a number of occasions, but effectively for the BIM model to work in the way it should, it has to be the building user who owns the model at the end of the day. Another issue is communication, which is clearly essential for effective collaboration, which is at the heart of BIM modelling. There's communication in terms of language. When you're talking, for example, about the post-occupancy evaluation, there are a number of technologies there which the language may not be familiar to various people within the team. And if the collaboration is used more widely, then a number of different people will need to become more conversant with the technological aspects of these theories. There's also lines of communication with people being involved throughout a linear process in BIM modelling. For example, a facilities manager at present is unlikely to have much to do with the design stage and would start anew once the building is handed over using O&M manuals. It's imperative that the facilities manager becomes involved much earlier on in the process through the design and the briefing, and then it's a more seamless handover at the building handover stage. Clients also need to be informed and effective at briefing. So if there are technologies that are used within their estate, then the design team need to be made aware of these early on so they can be incorporated into the design model. There's also the aspect of technical communication, and software vendors and data providers need to work together, which they are already starting to do, to make sure that this information can be effectively communicated. And finally, the compatibility is an issue. Small practices are balancing the concept of either becoming an early adopter of technologies and using that to commercial advantage, or worrying about jumping onto a technology which may become obsolete. Use as an example the VHS versus Betamax, or to use the analogy and bring it more up to date, perhaps Blu-ray versus HD DVD. Where a technology, two perhaps software packages run hand in hand, and people invest in one, it becomes obsolete, and then the investment is seen as not value. There's also a compatibility between various stakeholders. The design team might change, there might be small subcontractors down the supply chain, and their software needs to be compatible to ensure that everybody's working under the same umbrella. So finally, to move towards BIM, it needs a paradigm shift in thinking and work, and a more joined up process, and it needs to go beyond just the technological process. It's a general shift in mindset. The collaborative environment needs to be developed, and the feedback from this environment needs to be fed back into the process to inform the BIM as it's ongoing. We need intelligent clients who can be effective at briefing, and not just involved at the post-occupancy evaluation stage. The facilities manager needs to be involved right from the briefing stage through design and construction. And as we've already highlighted, software and data producers need to work to produce easy-to-use information that can be easily shared. So although post-occupancy evaluation would lead you to believe that it's once the building is handed over, the process must start at the outset. We need to manage aspirations and expectations from the client, and everybody needs to collaborate for effective delivery. And in the end, effective post-occupancy evaluation will ultimately lead to optimal asset performance. I could hand back to Ibrahim now just to draw the conclusions.
Okay. Thank you. As Wendy said, the industry actually is facing a lot of problems actually in even adopting normal BIM, and not even talking about the use of BIM in post-occupancy evaluation. While we can say that the current type of research try to tackle these type of problems from the technology point of view, and as well the industry itself and the initiatives that we can find in the industry and even in the governmental from the government point of view as well, is trying to solve the problem in terms of investment or financial aspects that is needed for such type of technology to be adopted by, I can say, at least the major clients. I can say that the technology itself becomes, of course, more known than before. A lot of solutions, or some solutions, try to tackle these problems. For example, I remember from it's not part of our study, but just to give example of solutions provided by the industry, by the development industry in terms of BIM and BIM technology. While you can buy the surface, not buying the technology itself, so you can have a third-party provider who can provide the surface, and you don't need to invest a lot. So this is an issue which concerns a lot of contractors and clients. In terms of technology as well, compatibility issues and these sort of things, you may be aware of the standard, or the information exchange standard COBI, which is now used by majority of the softwares to make all softwares compatible to BIM in general. So any type of technology or any type of software that should be developed from now on should be compatible with or should use this type of standard, because it is clear now that BIM is going to be used in majority of projects in near future. So this is part of the type of current research, and from our study, and we just here first identified the key variables, as we mentioned just shortly before, that this type of structure would show us the source of information or source of data that should be used for post-occupancy evaluation, how we deal with it briefly. I mean, just to cover this briefly in this presentation. And the next step is actually to take this type of framework of data management or energy management and develop what we call in terms of IT ontology, energy management ontology, which means we try to have the skeleton of that system, which define each piece of information or data, where it comes from, who will use it. So we have an information flow, and very detailed information flow, with every piece of information and data is defined in actual terms, and who would produce it and who need it. And we have this type of structure which help us understand how the energy data is used and analyzed, and link this with BIM model, which means that all this type of data will be linked with each relevant element, and then you can use your BIM model here with the type of ontology or the type of structure of data used. If we are able to link these two type of models together, that means when you come to monitor your building, so you are aware of the type of data you need to collect as a energy manager, and you are aware of the type of energy performance of the building for each element, for each space, for each zone. So that means you link your data that you collect with the building you are occupying. This is the way forward, we can say. We just start to understand how this data is collected, and who is using it, and who produce it. The last part of our conclusion here is to include the element of knowledge, as we can say, as we are talking all the time here about data and information. While from our study, from our discussion with the experts, they are saying, or those energy managers in different public departments, as we mentioned, they have huge number of buildings, huge number of sites to look after, and of course they may come across different type of problems in different buildings, and those teams who are looking after these buildings, they may not be connected enough to learn from each other. So the level of knowledge exchange, you can say, between these teams are not exist yet, or is not existing yet. So that means we need to develop a kind of model as well that help these teams to learn from each other based on the experience they got from working in certain buildings. So another way forward from our study is to look at how we can model this type of knowledge. Again, it's quite, you can say, another aim to have it in another study to understand well how this knowledge can be captured and coded, and how can we include it in that type of models. So by the end, the future of BIM will cover this level as well of knowledge, which we mean by the end we will end up what we could, but by what they call now building knowledge modeling. So we have here this term which is now start to be used for construction IT to move from BIM, building information modeling, to the most sophisticated or high-level modeling, which is building knowledge modeling. So this is another direction actually for this type of work, which we hope we can do some other work for that. And thank you for listening.
Thank you very much, Ibrahim and Wendy. And we can now start with questions from our audience and some comments. Here is the first one from Bruce Newlands of Craft Architecture. This is more of an observation than a question, but every time I look at BIM, it always seems to be focused on the planar elements, but never the connection between these elements, i.e. thermal bridging, condensation risk at junctions, specific conditions at exposed, sheltered corners, etc. This seems to be an area that requires more work.
Well, I mean, as we just briefly mentioned in our presentation, that there are a lot of tools and techniques used for energy analysis and for any other environmental aspects analysis, which could be linked with BIM or could be just standalone applications. Yeah, few of them start to have versions which can be compatible with BIM. So you can link the BIM model, the building BIM model, with any type of analysis we need. Of course, this area is not complete yet. I mean, there is a lot of work should be done in this area, including the examples that our listener actually gave. Yeah. So I'm not fully aware of all the type of application which are actually now compatible with BIM, but I know a few of them.
Yes, this study focused on energy efficiency and monitoring energy efficiency, but there are other aspects of sustainability that have to be considered. Do you believe that BIM should be linked in future with environmental assessment methods for buildings such as BREEAM or similar?
Yeah, there are some we can say studies or initiatives in this area which try to expand or integrate a BIM model with a tool or a device that issue BREEAM certificate, or so there is something in practice now, but not widely used. Again, could be mainly I've read a number of studies which actually already developed a tool which produce LEED certificates in US, not following BREEAM principles. So there are potential in expanding BIM model to assess buildings based on this environmental issue, general environmental aspects, not just for energy. Yeah.
Training issue is very interesting, and also prospect of future employees in building management or facilities management, because obviously there will be a need for skilled staff who know how to use BIM and how to engage with building designers, with engineers. So that is a really potentially new area of professional training, which is very important and will be forthcoming. Any comments on that?
I think at the grassroots level that's already coming through in the colleges, and students are being taught more of the concept of 3D modelling, so it's less alien to them perhaps as it is to people of my age in the industry. But yes, it's a shift.
I myself actually at Heriot, as I am lecturing there, I myself teach 2 courses for undergraduate students, which actually use BIM as a platform. And I'm aware as well of other courses which link BIM to their contents as well. So this is in terms of graduate or students. There are a lot of as well initiatives for other maybe training courses or so. So definitely the way that we look at this technology, new technology at the moment, remind us of the way that we looked at CAD systems when it started to be used in industry. That it was the same kind of scenario that people are familiar with hand drawings and these sort of things, and then they, bit by bit, they start to use CAD systems, which now become something which is essential for any graduate or any practitioner. So yeah, I think we are at that transitional period now. Yeah, so it's same kind of history, you can say, is just repeated now.
So can BIM be developed for existing buildings? And because it is important really to look into energy efficiency of existing buildings. How time consuming is that? What would be your estimates? Has it been already developed for existing buildings?
I'm not sure of any specific case studies where it's been developed for existing buildings, but I'd imagine there'd be an awful lot of information to be fed in for it to be an effective model. You're not having the natural process of specifying materials and that information being embedded as part of the process. You'd have to go back and survey the buildings and input a lot of data before the model was of use. But I'm sure as the use of BIM develops, the methodology for carrying out these surveys will improve, and over time become useful.
There is again some trials, you can say, started to do that, but again it depends on the cost and benefit analysis of the case. It's not, I can say, a common type of application now. So they use the laser scanning technology to look at planning or get a full picture of the buildings. Could be more. It's quite expensive at the moment, of course, to have this type of exercise, but it depends on the importance of the process in scanning a building or so. So yeah, it's still, the technology is still expensive, but yeah, the potential that it will be much cheaper with more advanced technology. Yeah.
Again, one question from Bruce Newlands of Craft Architecture. Is there an issue about the cross-compatibility between different BIM software suppliers? Should there be an open source CAD BIM system that suppliers can freely plug into and that specifiers, including small businesses, can utilize? I'm worried that the big software houses that we know from the CAD world seem to be building another monopoly in this very interesting technology.
Again, it's part of the problems that the industry faces to have this type of compatibility issues solved. And from the technology point of view, again, as just briefly mentioned about COBE standard. So now this standard actually should be now followed by any new developer. Any software developer wants to be compatible with them should follow this standard, which solve this problem. Partially, you can say. So a lot of softwares now currently are not compatible with BIM, regardless of the type of output is used, or the type of analysis they are doing. So the developer of these systems tried now to have other versions, new versions, which compatible with BIM. That means in few years' time, this problem shouldn't be there at all. I mean, the industry tried to solve the problem, but it will take some time until we reach up to this fully compatible softwares.
In your presentation, Wendy, in your talk, you mentioned the cost of the investment in the whole system, and especially as a barrier to small and medium-sized enterprises. Does it mean really that we will see only larger companies, larger practices using BIM because they will be working for larger investors or public sector investors? Or how do you see the future of the use of BIM, and how you would suggest the barriers could be removed?
I think that the costs are a barrier whether you're a small or a large practice, because they're just multiplied by the number of people in your practice. So it's a barrier to anybody if you see it as a barrier. As technologies advance, I think costs will come down. As people come through the education system who are used to using the software, the investment in training will become less. Certainly I see larger companies being the pioneers in a way, because there is the incentive there for them to maintain large clients. But I think that the momentum will gain very quickly, and that small to medium-sized practices will adopt them as a...
Yeah, just to add a small thing about this as well, same point. Actually, one of the reasons that the industry doesn't take this type of initiative or this type of technology, ahead at the moment, because mainly they look at BIM as a design tool only. So they thought that if instead of CAD system we just use BIM model. But if we expand this type of understanding to say, okay, if we need BIM not only for design and construction, we need it for post-occupancy evaluation. So that means the model that we develop now will last with us until the full lifespan of the building. So that means there will be more justification or real justification for investment at the moment in this type of modeling. So I think, if we just have this type of link between the energy use or any type of environmental assessment of buildings or the post-occupancy, we can say, so that means we can justify the investment at the moment, not just at the design stage, which again, this is one of the issues that all the clients and contractor or practitioners say, okay, we cannot use this type of investment or invest this huge cost just for this period of time or this stage only for that building. So I think, with time, and with more use at different stages, the costs can be more justified. Yeah.
How would you envisage communication with end users, with building occupants, who, as you mentioned in your presentation, really can influence our energy efficiency or reduce energy use in buildings? So that the information that we obtain from BIM system is not only kept with building managers, but communicated to building occupants in a way that they can understand and act accordingly to reduce energy use.
I think it could be used quite effectively from early on. You could demonstrate clearly what the benefit would be for opening windows, for example, as opposed to using an air conditioning system. You could put costs against that early on and use it as a demonstration tool for these technologies.
We don't have any more online questions or comments from our online viewers. What would you say at the end of the summary, or what further research do you see that is forthcoming to increase the use or develop BIM further?
Yeah, so there are different things actually. In terms of energy analysis and use, actually there are a lot of work now to try to have a comprehensive systems which look at the more specific energy analysis tools like IEM, or what you call it, IE virtual environment. So I think they have a kind of work with BIM softwares to have a compatible or an integrated system. So that means we will in future will see a full system that actually take the BIM model with full analysis of energy use. But again, this is mainly for design stage, not for post-occupancy. If we expand this to knowledge, as I mentioned in my presentation, that if we include the experience with people as well, the experience of managers in terms of solving problems related to energy or any other aspects. Here we are talking about energy, but it could be for any other environmental measure as well. So the expansion will start bit by bit. So those who are interested in energy will start to integrate with BIM. Those who are interested in water, for example, water management or any other type of aspects. So they start to have this type of links. So by time we will have more complicated systems which actually cover all environmental aspects.
Regarding the use of BIM in practice and how to increase that use, do you believe, Wendy, that maybe the cost of including BIM information or using BIM should be charged to building clients? Because they will be the beneficiaries at the end of and users of this system, information from this system.
Yeah, I'm not entirely clear how that would work, but I think that what you might see is that a lot more of the fee being front-loaded, so stages A to D effectively of the REBA plan of work, there'll be a lot of information going in at that stage, and there'll need to be some kind of reward for that, for the people that put in the work at that stage. Yes, and then the model will be handed on to the client, and the client will have ownership of that.
Okay. Here is a question from Bruce Newlands again from Craft Architecture. There is a fascinating opportunity here to model Scotland's existing stock, domestic and non-domestic, and use this as a way of informing new building regulations, i.e. virtual evidence-based regulations. That is really an interesting potential that will require some funding to collect all that information, but that would be great. And another comment from Huda Salman of Robert Gordon University. I think such post-evaluation testing should be pioneered and mastered by councils, as they can test it with their stock of buildings or some of their buildings. For example, the ones that are eligible for reinstallation and energy performance measurements. Another suggestion. So there are lots of possibilities of how BIM can really contribute to increasing our knowledge about energy use in all types of buildings, existing and new. Well, we do not have any more comments, and I would like again to thank you for your presentations and to thank our online viewers for their questions. And before we end, I would like just to draw attention of our online viewers to our future events. The first forthcoming event is a webinar on developing a template for quick start home user guides. This webinar will take place on 3rd of October, and it will showcase outcomes of a study undertaken by Macintosh Environmental Architecture Research Unit at the Macintosh School of Architecture for Home Logbook Company. Following that, really the next day, following day, there will be a conference, Eco and Energy Efficiency Improvements in Hard-to-Treat Housing. That is on 4th of October in the morning from 9 to 2 o'clock, 2 p.m. And this live conference will take place in the Lighthouse in Glasgow. So as this will be a live conference, there will be no online transmission. You are very welcome to access our website to find more information about both webinar and this conference, and